Hi IT lovers of my classes, welcome to Easy Machine Learning Nr.1 6 with Python on Google Colab. Of course, again, I invite you to watch my previous Python and machine learning tutorials. Today we move on with the Iris flower project started last week. We are building a machine learning model that can predict the species of an iris flower based on its measurements. First, we saw the iris flower in pictures, the actual beautiful iris flowers. Then we imported the necessary libraries. We loaded the dataset. We could then split this dataset into training and testing sets. And we started to initialize and train the KNN-Classifier. Now let's move on. We are going to print the iris dataset just to take a look at it. Then we are going to make predictions on the testing set and evaluate the model, etc. Let's finish this iris project today, amen. Thank God again, I'm going to tell you the same thing in German and French. Hallo Leute, willkommen zum einfachen Maschine Learning Nr.1 5 mit Python auf Google Colab. Heute geht es natürlich weiter lade, ich sehe Irisblüten-Projekt, auch meine vorherigen, letzte Woche, gestartet, Machine Learning Tutorial. Wir entwickeln ein Modell, das die Art einer Irisblume anhand ihrer Messungen vorhersagen kann. Zuerst haben wir die Irisblume in Bildern gesehen. Das ist eine schöne Blume. Dann haben wir die nötigen Bibliotheken importiert. Wir haben auch den Datensatz Upload gemacht. Wir konnten diesen Datensatz in Trainings- und Testsätze aufteilen. Und dann haben wir mit der Initialisierung und Trainierung von KNN-Klassifier begonnen. Heute machen wir nun weiter. Wir werden den Iris-Datensatz ausdrücken, dann Vorhersagen für den Testsatz treffen und das Modell auswerten und so weiter. Wir wollen das Iris-Projekt heute beenden. Donc, shalom à tous ceux qui apprécient mes cours de IT en ligne. Bienvenue chez Initiation au Machine Learning numéro 1.5 avec Python sur Google Colab. Bien entendu, je vous invite aussi à regarder mes tutoriels de Python et Machine Learning précédents. Aujourd'hui, nous allons poursuivre avec le projet de la fleur d'iris démarré la semaine dernière. Nous sommes en train de construire un modèle capable de prédire l'espèce d'une fleur d'iris en fonction de ses mesures. Nous avons d'abord vu la fleur d'iris en image. Ah, c'est une belle fleur. Hein? Ensuite, nous avons importé les bibliothèques nécessaires. Nous avons aussi importé les données. Nous avons pu les diviser en ensemble d'entraînement et de tests. Et nous avons commencé à initialiser et à entraîner l'algorithme KNN. Passons maintenant à la seconde partie du projet. Nous allons imprimer les données d'Iris pour les voir aussi. Puis, nous allons faire des prédictions sur l'ensemble des tests et évaluer le modèle, etc. Nous allons finir le projet Iris aujourd'hui. Dieu merci encore une fois, je vous ai dit la même chose en anglais et en allemand.
Okay, you remember we stopped by initializing and training the KNN classifier. So right now I'm just gonna first comment all these so we can print the data set. And then we're going to uncomment all these afterward. First, let's print it so we can take a look at it. So here we write print, of course, in lowercase, print iris, simply, like this. And then we can see. Now let's run and see the printed iris. As you can see down here, let me scroll down. These are the iris data. But for me, you know, it's too long and too big, so I'm just gonna do something else. I'm going to comment this one Just wanted you to see the command of printing your data set. So I'm going to comment it and do it in another way. I'm just going to create a data frame with the 4 feature variables and view only the top 5 rows, for instance. So in order to create the data frame, it's df equal pd dot data frame. We have to let me go back and get a real pg and not pe. So data frame, and of course we have to precise that it is iris data, and we want first the column equal iris, and we want dot feature names, and the parenthesis is closed, and after that I want to see the head. So here we are going to df again and dot head. Now we want to run and see what's going to happen. I hope you remember right now we have all the data here. I mean, it's long, and the top of it, let me show also the top of the page, the data. So I have to go back to the top just to show you that it looks like a dictionary, a Python dictionary, data array, blah, blah, blah. And normally at the end, they tell you also the number of rows, the total number of rows. Let me see if we can see that. 2. This is when we scroll here, we can see more. But as I said, let me go back to the top and run this part. We want to see only the head. So when we run, this is what happens. Here we have the sepal length in centimeter, sepal width, the petal length, and the petal width. We have only the 5 first rows. You remember that it starts with a 0, that's an index, and then 0 until 4, these are the 5 top rows. Okay, I just wanted to show you how you can take a look at the data you just downloaded or uploaded on Colab, the Iris load Iris. And then we wanted to print the whole data. We did it, and now I commented it, and then we printed the head. Okay, I'm going to comment all these and uncomment where we stopped last time. So as you can see, I added that the system shall recommend us the next step. Okay, so I commented all that, and this is where we stopped. Now I can get rid of the head, so we can move on. And this is how you do it. You come here by the output and you click on the cross, so it's gone. Now we can move on. So now I'm going to add another comment. As I said, make predictions on the testing set, and it's going to be y pred and equal KNN dot predict, and we want to x test, and then after that we want to evaluate, as I said before, we want to evaluate the model, and we need the accuracy equal accuracy score. We have it here suggested, so we take it, y test again, and y pred. Okay, after that we want to print the accuracy, of course, we're gonna get this one in columns, accuracy, and again accuracy. We have to indicate all the time, and then we want to print the classification. Print classification, and the classification report. Of course, we have to indicate again what we are talking about all the time. Y test and Y pred. Okay, and after that we need to go back to our libraries. Here we're gonna get from sklearn we need the matrix, and import the confusion matrix. And we are going to import also the seaborn. So we have to make sure we type right the sklearn matrix and the confusion matrix. They sound the same almost. Import the seaborn as SNS. And after that, let's calculate the confusion matrix. We're gonna comment first here, calculate confusion matrix. So it's going to be CM, like confusion matrix, CM equal confusion and we are going to indicate again Y test and Y pred. So as you can see, the popping up window here, you always have more details about what you are typing, what it means, etc. So this is how you can improve your skills. Okay, next comment is going to be plot. That was a recommendation actually of the system to plot. So we are going to plot the confusion matrix. It's going to be plt dot figure, and figure size is going to be fig size equal, here we're going to get 8,6, and SNS dot heat map CM equal true, then CMap blues, and the FMT is going to be equal so FMT is going to be D, the X tick labels iris dot target names, Y tick label iris dot target names, and we move on with the PLT. Let me go back. So here we move on with the PLT dot X label. We want the prediction here, we said predicted label, predicted label, and then we want the Now the PLT Y label too. And this one we want the true label. After that we want the title also. I'm gonna plot the title, plt dot title, and here we want the confusion matrix. After that we want to show, so plt dot show, and that's going to be a method. So we are good with our project, and this is the end of our project. Now we can just run it and break it into steps. All right, let me just show you the whole one, the whole project. And the comments are very important, so it helps you, you know, to know where you're at, what you're doing, and stuff like that. Okay. All right, now as you can see, we are ready to run. So we run, we see the output, and then we can break it down in simple terms, what it all means. Okay, let's run. So if it's not red, it means everything is all right. As you can see, it's green. Okay, now we can see the results. So as you can see, accuracy is 1.0, which means 100% accuracy. So the model worked pretty well. Now let's break it into simple terms. As I said, here's a precision. As you can see, here's a precision. Is the number of true positive predictions divided by the total number of positive predictions made by the model. It tells us the proportion of correctly predicted positive cases out of all predicted positive cases. In this project, precision for each class like Setosa, versicolor. Let me go down so you can see. Yes, Setosa, versicolor, and virginica tells us how many of the flowers predicted to belong to that class actually belong to that class. Now the recall or sensitivity, let me go back up. Here you see after precision you have the recall. Or sensitivity is the number of true positive predictions divided by the total number of actual positive cases. It tells us the proportion of correctly predicted positive cases out of all actual positive cases. In this project, recall for each class tells us how many of the flowers of that class were correctly identified by the model. And then as you can see here, we have, we're still here. After recall, we have the F1 score. What does it mean? F1 score is the harmonic mean of precision and recall. It provides a single score that balances both precision and recall. It's useful when you have an uneven class distribution. And then we have the confusion matrix here. So the confusion matrix is a table that is often used to describe the performance of a classification model. It shows the number of correct and incorrect predictions made by the classification model compared to the actual outcomes. In this project, as I said, we used the Iris dataset, which contains measurements of different iris flowers, the Setosa, the versicolor, as you can see, and the virginica. And our goal was to build a machine learning model that could predict the species of the iris flower based
on its measurements. The thing is that, as you can see, we trained the model using the key nearest neighbors, KNN algorithm, and we evaluated its performance using, you know, accuracy, as you can see, precision, recall, and, you know, the confusion matrix. So essentially, we looked at how well our model could predict the species of the iris flowers. And we found out the accuracy of predictions and how often our model correctly classified flowers into their respective species. So we have an accuracy of 100%. And then, as you can see here, we have some other terms here, the macro average and the weighted average. But before we start talking about the macro average, let's talk about this support right here. After the F1 score, we have this word here, support. What it means is that, well, support represents the number of occurrences of each class in the true labels. In other words, it shows how many samples belong to each class in the test set. So now the macro average is, you know, it calculates the average of the metrics, such as, you know, precision, recall, and F1 score for each class independently, and then takes the unweighted mean of these averages. It gives equal weight to each class, regardless of its size. And now the weighted average, right here, you see after the macro average, we have this weighted average. It calculates the average of the metrics for each class, weighted by the number of samples in each class. It gives more weight to classes with more samples, providing a better overall representation of the model's performance across all classes. These metrics are particularly useful in multi-class classification problems, such as this iris flower classification project, where we have multiple classes to predict. They provide additional insights into the performance of the model beyond simple accuracy. This is what all these metrics do. So this is the output. I hope you understand what we did. So this is the whole file with all the comments, how we started and how we finished. Here I'm showing you the output again, just in case you wanna copy. All right, we are good with our iris flower project. I hope you liked it. All right, thank you for watching. The rest is coming next if God's willing. Until then, may He bless you. Bye-bye.